Hello everyone, and welcome to lesson number 6 of my deep learning course. Sorry if I couldn't upload any content in the last couple of weeks, but I wasn't at home. But now I'm back, so we can continue with our usual schedule every Sunday. So without further ado, let's get started. Whether you want to implement AI into your business or you just need consultancy from a machine learning expert, I'm the right person for you. From acquiring data till deployment, my multiple years experience will provide you full support which will help you to boost your business. To find out more, check the link in the video description. Welcome back everyone. So in this tutorial we will see another popular activation function, tanh, and we will implement it from scratch in our neural network. So as always, you will find the link to where to download this file in the video description. And if you guys have not seen my previous videos, you can check out lesson 1. So in that video, we set up the Jetson Nano for deep learning. So you can follow along right from the beginning and you can get them to this point. So as always, we have the video for this lesson. It's going to be replaced as soon as I upload this video on YouTube. So now we start, as always, with the question, why using tanh? So researchers, like me, always trying to find new algorithms which help to train neural network faster and better. As we saw in lesson 4 and 5, sigmoid outputs within a range between 0 and 1, which causes problem when we have negative values, of course. tanh outputs instead within a range of -1 and 1. So it can also output negative values and has the following formula. So the output is equal to exponential value of x minus exponential value of minus x divided exponential values of x plus the exponential values of minus x. So it might sound a little bit complicated. So as always, we will first visualize this activation function in a graph, and then we will implement it from scratch in our neural network. So as always, we need to make sure that we are running this Jupyter notebook with the TensorFlow 2 virtual environment so we can execute this code. If you guys get any error, then you just need to go up here and select TF2 as a virtual environment and then restart the Jupyter notebook. Okay, so first let's visualize this function to understand how it looks like. So we can execute this code, and in this code I have an input, a series of inputs, specifically 100 data points, equally distributed within a range of -10 and 10, and then we hard-coded here with the tanh function the function itself. We could have also used numpy.tanh, but to show you guys how to do this very low level, I implemented like in the formula. So here is the graph. And as you can see, this function has the same S shape like for sigmoid, but this time is in the range of -1 to 1. And with an input value of 0, the output this time is 0, not 0.5 like in the sigmoid function. And of course, the further we go from this input of 0, the higher or lower the output is, until we reach a plateau, as you can see here, guys. So from the minus and the plus directions. And as you can see here, we have most of the variance within -1 and 1. So as you can see, when the input is between -1 and 1, we have a big difference in the output. Between -1 and -2, you see it's pretty low. Of course, this is mirrors also from 1 to 2. And then below -2 is basically almost no change in the output. Okay, so now let's create a multi-layer neural network from scratch using tanh activation function instead of the sigmoid as we were using in the previous videos. So like for sigmoid, if we want to implement non-linearity into the networks, we have to apply some activation function after each layer. So in our neural network class, this is the same like in previous videos. nothing has changed, so the constructor is exactly the same. What I've added is only the tanh activation function, which is here. I still left the sigmoid function from the previous video. And as you can see, I implemented the same formula like when I was using before NumPy. In this case, I used TensorFlow operation. But like for sigmoid, we could have simply used tf.math.tanh and would have been exactly the same. But since I am writing everything really low level, again, I implemented the formula by myself. This time in the call function, of course, instead of using the sigmoid, I just called the tanh activation. For the rest, the class remained exactly the same. So then we can execute this code. Then we have the loss function, which is like before the same, so mean absolute error. So we can also execute the code, nothing has changed. Same also for our training function, nothing has changed, everything like we have built it up to this video. So I will not repeat myself. Now we will train our neural network using some sample data that I provide in this code block. And this time the expected output is going to be a simple polynomial. So the input values, as you can see, are 0.1, minus 0.6, 0.2, minus 1.1, minus 0.2, and 0.6. And the expected output applies to those inputs, this polynomial, in which we have x squared plus 3x minus 1 to get the result. And that's actually what I've implemented here simply. Then we convert those NumPy arrays into TensorFlow constants instead of variables, so they're, those values don't have to change, so it's faster for training. And then we have the same network, so two layers in our network. We will train for 50 steps. The learning rate in this case is pretty high, so that we can speed up the training. And then we initialize our neural network as usual with the weights of 2.0. Then we repeat the training and we print then the output. So we can execute the code at this point. Okay, so we can see the loss is start on a pretty reasonable value, 0.9, and then decreases pretty fast till after 50 steps we get 0.18. Now when we go to the comparison between the prediction and the labels, we can see that the network did pretty well. So in the first element is almost exact the same. So it's minus 0.685 and the label is minus 0.69. And then we have some differences, for example, at this point with minus 3.09, the label, but the rest is pretty much good. So I don't know if you guys have noticed, but the labels here are pretty small. So we get 0.69, minus 2.44, and so forth. We have only one value, minus 3.09, but are pretty small. We don't have something like 50 or minus 100 or something like that. So this is also a good hint when we want to analyze our data and everything. Since we have everything as a small output, maybe we need also to see what happens when we have bigger outputs. So for this reason, now it's time to experiment by yourself. And I want you to try it out, this code block, where I provide new data. So feel free to change neural networks parameters and the number of training steps. So within those 4 lines, you can change whatever you want. After those lines, then this part of the code has to remain the same. And just for you to show what's happening, let's run this code. So let's execute this code. And as you can see, this time we have a loss pretty high. We start with a loss of 31. And then when we go down, we see still 30. So it's really not going much down. And we have some problems here because the labels was expected, for example, 21.75, and the prediction of our model is 2.17. So very far. And it's impressive, actually, the last output. It was supposed to be 119.96, and our network predicted 2.17. So we have a huge distance. So the network is not doing a good job in this case. So as a bonus question, so of course, as I mentioned, try to change the parameters and see if change something, and if it is, what change. And then as a bonus question, can you explain why this strange behavior is happening? And to help yourself, you can check the lesson number 4 and lesson number 5. I have left 2 handy links here so that you can check it out, lesson 4 and lesson 5. So where I explain how to debug neural network. So this is very useful to solve also this task. Well, now we reach the end of the video. So in the next lesson, we will learn some more activation functions. And I promise it's going to be the last time I'm going to speak about activation function, at least for a little bit. If you're wondering why you should know all this stuff, so all what we're explaining so far is that think that by knowing each component in the neural network, how it works, then you will be able to develop some intuition on how to design a neural network. So as long as you guys use some state-of-the-art network and you apply it on a new data set or in your application, that is totally fine. But then when you want to design something by yourself or you want to improve something by yourself, then you might struggle to know from where to start. You might just have worse result than from the beginning. So it's really important to understand each component of the neural network, how it works, so then you can also design by yourself and experiment and develop some intuition. You guys cannot imagine how many times, especially if you go to interviews, I've interviewed other people in which I was asking, okay, what have you done? They were telling me, okay, I have implemented this, and this network. And then I started to ask, okay, how does this network work? So if I want to ask, okay, explain me how does this network function, so how it creates the output. Almost nobody was able to explain. And it's fine as long as you do some kind of job. It's totally fine. You don't need to go too much in detail. But for other jobs, it's really necessary to understand what at each step is happening in the neural network. So I a little bit deviated from the topic of today's video. Anyway, you might be wondering, if you're a little bit more expert in deep learning, why are we using sigmoid and tanh in those videos? Even though those are functions which are not really used at the moment, so are at least in the way that we are using them. So after each layer, a sigmoid or a tanh is really not used anymore. But the reason why I'm still explaining them, because sigmoid and tanh are implemented in bigger blocks of code, for example, in LSTMs, which I will talk later in the video. So that's it for this video. If you guys like my content, you can support me on Patreon, where you can speak directly with me, and also I can give you advice on how to get started into this career. Another way to support this channel is to use my affiliate link that I give you in the video description for your purchases at no cost for you. Finally, another way to support me is to subscribe and share this video on social media. So I thank you for now, and I hope to see you in my next video.